Okay, so for our progress now we're in week 12, isn't it? Yeah, 12 or 13? 13, yeah, should be. Or 14. Now it's week. Yeah, we only have 2 weeks left, yeah, before the exam. Okay, so you may also have a look on the when I check my Google Calendar. The exam would be on December, I think. Let me check. Yeah, yeah, this one. Yes. So you will have exam on the 8th of December. Okay, so this one is uh, the module 3 exam about extraction. Okay, so um, now we're in wait. So now we're in and yeah we're in this one in the 18th of November, so we still have 2.5 week, yeah, for before the exam. So what I'm going to do now, so today you can open the module 12, yeah, this one in module 12. This is should be done last week, but looks like you're preparing for the exam about the absorption. So uh, um, Fabian, can you mute? Okay, okay, good. Right. There's no lecture at the time, yeah, last week. So now today we're gonna talk about the pack column design. It's not much because we know the basics. And then next week, and then tomorrow, so Friday, next next week, and then next 2 weeks. So there are maybe 2.5 weeks. We're gonna start uh, talking about extraction. I also have put all the PPT in here, yeah, the handout. So you may want to have a look what it looks like, and then before the exam. Now, for the tricolumn, presentation, how if we have a presentation on next Friday? How about that one? I have time between. Okay, I have time in the morning up to about 12 o'clock. Do you have any classes, or do you have any classes around this time, Friday morning?
I think we have an Alpro exam,
Right.
right? On Friday 26th. This is, yeah.
In the morning.
Guys, it's in the morning, right?
I think outdoor is from 7 a.m. until 9
Oh,
a.m.
okay. So you count to that, yeah. Okay, then I need to check the time then. Okay, right. I was thinking we have time around yeah 3 hours straight, yeah. So because you have three groups, so let's have a look about 3 hours straight. That I will check your report again and then let you know. Yeah, I will be little bit busy, little bit it's a bit quite busy next week and also the weeks after, I think. But let's have a look. Yeah, I'll try to check which one that I can put the presentation. Right, okay, go back to here. So here, so we have the extraction. So now we gonna so now I'm gonna go back to start the presentation about pack column. Okay, just to remind you about the presentation that I gave a few weeks ago. uh, Usually the um, pack column or tray column, usually we should be able to do the tray column presentation soon, so you can get feedback about your design, and then you have more ideas how to design the pack column. Yeah, hopefully. Yeah. Okay, so after this, or you can see the assignments as well on the MS Teams. Your next part is to design the pack column, the pack column for absorption. Okay, this is very important because just wait, I need to put close the door. Okay. Yeah. So the oral exam, even for the tray column and the pack column, it is good in a sense that it is take about 40% of your total exam. Yeah, because we have 5 exams, so it counts 40%, and usually the mark would be much better compared to the written exam. Yeah, so that's actually advantages, and also give you skills about how to design something. Yeah, which is you should experience with your trial column design. Okay. Just a little bit feedback on your report. In the specification sheet, it's like if we want to design something, or if you want to buy a design, when we want to buy, let's say I want to buy Lego toys or something, yeah, I would look at to the pictures. Okay, so the schematic, or the schematic of the equipment, the measurement and the schematic, the technical drawing is very important in the specification sheet. Yeah, I think most of you didn't put the specification didn't put the drawing of what is your columns like, but we would like to see, yeah, if you want to buy something, you need to imagine what is these things like. Yeah, so if you want to design the tray column, then uh, how much is the height, how much is the diameter, where is the manhole, where is the side hole, what is the type of the cap, yeah, what is the spherical, where is the all the parts you really want to know. Okay, so this also the case with the pack column. So in pack column, later on when you want to design, you also need to consider about the manhole or the manway. Yeah, this one is the hole and manway, and then the distributor, or the where is the vapor feed comes from, or where's the vapor out. Yeah, the that one there, or the, and then where is the liquid feed, and so on. Okay, and then you also need to understand that the height of the packing, if you look at here, the height of the packing, or the height of the packing tower that you design is just the height of the packing. Okay, if you look at here, this is the tower, a typical tower. There are like a room inside here. Yeah, for the cap, for example, for the there's a quite few rooms there are few rooms there. So your total height of your column later on when you design should be the total of the pack column, the packing, with addition with some other accessories. Okay, so you need to consider that. Right. Okay. So this is just to we also talk about the type of distributor, the type of packing, yeah? And then you may want to have a look these slides. Um, now, now let's start checking the pack column for today. Okay, so now what we would like to do, what you should aim, or what can you expect from listening to my presentation is you should be able to know how to design or how to determine the height of the pack column, yeah, and also how to design the column. Okay, so um, it is very basic, not basic, yeah. We know it already, and then you also had had the exam last week, that the height is actually the height of the unit multiple with the number of the unit. Okay, for example, if we consider the overall gas, if we consider the overall gas, then the height is influenced by the HOG multiplied with the NOG. Okay, and then uh, if we consider with this basis with the overall gas, then it is we need the K, the capital K, which is the mass transfer overall for gas. Okay, and it is actually it also influenced by the small k, a small kg, and also small kl. Okay, so in the book, so you may want to revert to the CNOT book. Yeah, the Colson and Richardson that you should already have, and then find about the pack column design. Okay, so in the CNOT book that we can use, first yeah, that should be I didn't remember the pages, but you may want to have a look about the section about the column design. And first we calculate the NOG, okay, the number of transfer based on the overall gas mass transfer. Okay, to calculate NOG, in the book they use different approach. Yeah, do you remember what is the calculation, what is the formula to calculate the NOG or the NTU? It's the same, yeah. So if I remember correctly, it should be K, the sorry, GS dash divide KYA multiply with the integral to the dy, and then this is y minus y star. Okay, so that tells you that this part is the N, yeah, NTU or NOG, and this one is the HTU or HOG. Okay, if we do it manually, it takes a little bit of time, because first we have to draw the graph and then find the gradients of the relationship between y and the y in the equilibrium, and then find the gradient for a few times, and then find one by one, and then after that you can do the integration using trapezium method or rectangular method, and then you can get the number of NTU. Okay, so that is the one that you learn in the past few weeks, is just one of the option. Okay, another option is by we called it Colburn approach, which is correlates the NOG, the number of overall gas, with the degree of separation. We call it A, which is equal to L divided by mg, which is L is the L is the number, the amount of, or the rate of the liquid, and G is the rate of the gas. Okay, so and then for much better approach, there is a correlation and empirical approach. So if you look at the next slide, there this is the Colburn equation. So this is based on the empirical equation. So based on many experiments, and then they plot it. Yeah. So we have this is called nomogram. Yeah, where you can you find a lot of them in chemical engineering, because the engineers like to plot the data, the outcome with correlation, and then it is quite empirical. Okay, so this tell you in this one is looks like this. This is from the book, from one of the book. It's called the plot of Colburn equation, the number of transfer unit for countercurrent operation. So it is the boundary, it should be a countercurrent operation, which is we have countercurrent, saling terbalik arah, ya. And then based on the Henry's law equilibrium, so we use law equilibrium, and constant A, or 1 over A, which is A is the absorption factor, or L divided by G, and M is the gradient at equilibrium curve. Yeah, so here they use small y. Yeah, they use small y, so there should be another graph concerning your equilibrium, which is small y and small x. Remember, y is the mole fraction. Okay, so in our calculation before, we use mole ratio. So in this case we use mole fraction. And then if I want to draw just a little bit about for example this one, yeah, if this is the Henry's law, so this is the M. Okay, so your M is, you got it from the gradient of the equilibrium curve, but make sure that you plot it only between the mole fraction and the in the liquid, and also mole fraction in the gas phase. Okay, so so here so that means if you know the this one, the number, yeah, this is the parameter is A, yeah, transport from Y to X, or 1 over A transfer from X to Y. So if you know your A number, yeah, if you know your A, you can check which one is your which one is your number, ranging from 0 point something, yeah, 0 point something to 5. Okay, and then you also can check how much is your degree of separation, which is this one, yeah, your y out minus y minus y out, and then divide by y in minus y out, there your degree of separation. And then you can get your number, you can get your NOG. Okay, so you can get your NOG there. Okay, have a look on the books and also on the books. There are typical maybe the good ranging of MGM over Ln. Okay, another one, this one also the same, yeah. Usually most students love to I think most students use this graph compared to the previous one. So they in this case it's also the same. They use the degree of separation is GM over LM. Yeah, I remember this. So this one is based on the equilibrium, and this one is from the rate of the gas, and also this is the rate of the L, yeah, or the liquid. Okay, check the books. There are a range of the optimum one. Okay, GM and LM usually between, I don't know, I forgot, between 0.6 to 0.8 or something. And then in the axis it is a degree of separation which is how much is y1 over y2. Okay, if you remember, what is y1? Y1 is the gas that's the feed, yeah, the gas that coming inside the absorption, and y2 is the clean gas. Okay, so you want to check what is your degree of separation. Okay, degree of separation. If, for example, if you want to have a higher degree of separation, you may want to have, for example, in this one, you want to have a high NOG. Okay, uh, so for example, let's say if you have a degree of separation, for example, okay, my degree of separation y1 divided by y2 is 20, so maybe around this area. Okay, and then you may want to pick one number which mgm over lm. Okay, and then over here, for example, I pick up 0.7, let's say, and then I can read it over there, and then read it over here, and I can read my NOG. Okay, so it is much better if you use the graph here, because you don't need to do the calculation and also to do the integration, yeah, the tabling, and then the integration. Okay, please check the book. Okay, check the book, the how to get which mgm over lm that is used much better to make a good NOG. Because I'm just gonna ask a little bit, what happen if you increase the L? What happen if you increase the L, or the rate of the liquid? You will need more solvent, right? If you need more solvent, then you will need more operating costs, yeah, especially if the solvent is costly, if you have to buy the solvent, yeah. Okay, and also you also increase the maybe the capacity for the pump, yeah, capacity of the generator, the desorption. Okay, and then yeah, that's gonna affect as well. Okay, so but for example, if I use large LM, so mgm over lm gonna be decreased. Okay, so if one decrease, let's say I'm gonna put, for example, 0.4 at 20 degree separation, I will look like that. And then I'm gonna read it here, so I will need, for example, the NOG I need is only 5. Okay, so but it means I have more solvent. Okay, you need more, you have more solvent, your mgm over lm gonna decrease, and I will have NOG is 5. Okay, now what happen if I decrease the LM? Yeah, the liquid is so expensive or corrosive, or yeah, expensive. Yeah, you can say that. So I have to reduce the LM. So let's say we make mgm over lm. If we reduce the lm, that means mgm over lm gonna be increased. Let's say I increase them up to 0.8. This one. Yeah, let's change the color. Okay, for example, this one, I'm gonna put it here, and I'm gonna read it over there. Okay, so it is around 9. So so that means if I have less solvent, then the mgm over lm is gonna be increased, then my NOG is actually around 9. Yeah, 9 something. So what can you see from here? Because the overall height is actually the NOG multiplied with HOG. So if you increase the number of overall gas, then you're gonna increase the overall transfer. Yeah, the height of the overall transfer. So that gonna make that's gonna imply that if you use less solvent, then but you will need higher tower. Higher tower mean more cost for your capital cost, the cost to erect the tower, to the cost for the material for the tower is gonna be taller. The tower gonna be taller. Okay, so this is about the trade-off between the height of the tower, which is the capital cost, and the the solvent, which is the operating cost. Okay, so that is the NOG. And the next one that you want to calculate in the assignments is also how to find the column diameter. Okay, you usually I will ask, okay, how to calculate the height and how to calculate the column diameter. Okay, before we calculate the HOG, the height of overall gas, sometimes it is good to find how to get the column diameter. Okay, the column diameter is actually using several time there. Sorry. So this one is there's a graph which is to find the K, and then the K is actually you can get the K if you know the LW star divided by VW star, and also square root of rho V over rho L. Yeah, so in a sense that we can find the column diameter once you know the area later on. Okay, similar to the tray column calculation, and then in the book also there are the rule of thumbs, which one is the flooding line, and also how much is the pressure drop. Yeah, the pressure drop that you want to see for the millimeter water per meter of pack height. Okay, and then here you can calculate the FLV, and then you calculate also this one, yeah, the factor and some sub factors, and then you will find is it the pressure drop, is it still inside the requirements, or is it over the requirements. Okay, so then maybe you want to do the iteration. Okay, and then for the HOG, this also there are two types of the method that you will find. You may want to check with the algorithm of the book. So maybe I would like to check the CNOT one here because there is no details in here. Okay, oh, I'm still sharing. Okay, am I still sharing the absorption? Hello?
You're not sharing anything now, Bu.
Okay, how about the previously? I'm still I'm still sharing the absorption or not? This one, sorry. Because mine was which one? Okay. Did you see this slides or not?
Yes, Bu.
But just now, yeah.
Yeah, just now.
Oh God. Okay, why didn't you tell me?
Because the slide was moving, Bu. Like, yeah. What do you mean, Bu? I thought you were talking about this one.
Do you see this one?
Yes, Bu.
Oh, before? Okay.
Yeah,
Good.
yes.
Okay. I thought I was it was in the previous one, and then I don't know. Yeah, I thought, yeah, it's good if you see my screens now. Okay. Let's have a look about the Coulson and Richardson. Just give me 1 second. Right. So it should be, so you may want to see on the, yeah, close to that one, yeah, the separation one and the pack column, yeah, you want to see this one, page 587. Okay, so yeah, you're gonna have this one. It is better if you can you can read, this one is for read, so from the beginning, yeah, so it is based on the, yeah, this one, yeah, the pack height, but from, so you want to try to find from the page 597. This one is the one that I just share it for you, and the second one is later on is the Cornell method. Okay, so in the Cornell method here you want to calculate the this one is the Cornell method. Let me go back to here. Okay, yeah, okay, so let me say, so here let's write that it is yeah, C C0, page 597 onwards. Okay, so the formula for the C0 is this one. Let's see. Okay, it hasn't been put it in the slide, so I think we just need to sorry, just to put it there. Okay, just to add more. Oops. Yeah. Right. So there are two methods to calculate the height, yeah, the height of transfer unit or the height of overall gas. Okay. The first one is by using Cornell method, and then you may want to check the more detail on the book, but just give me a sec about the formula. So it's basically we need to calculate the HG and also HL, and then after that we integrate them, not integrate, just to combine them. Okay, and then the HG and also HL comprise of many the properties, okay, such as the diffusivity, okay, in the liquid, diffusivity in the vapor, and also the L, or the weight of the liquid rate, yeah, and also there's a Smith number, and also some factor C, or epsilon or something like that, yeah, and also some function. Okay, so basically we have to calculate this one based on the properties. Okay, and after that we do find the z and then do the iteration again to find the real L. Okay, so this is, so in here we do a iteration to guess, menebak, yeah, to guess z, yeah. So we check about the z first, which is how much is the height, menebak, yeah, for example 10 meters, and then calculate the hg and hl, and then find the total height, and then do it again. Okay, and then you may want to find which one is the height. Okay, the second one is called the Onda method. The Onda method also, I need to open here again because it's not that one there. Okay, yeah, okay, yeah. So this is the kernel method. You may want to find there are some vectors about the flooding factors, and also this is also the factors based on the type of the packing. Okay, and then also here there's some yeah, that one there, just the percentage. And then the second one is called the Onda method. Okay, in the Onda method, you also want to find the k, the coefficients, and then this is all the formula. You want to find the wetted area or the affected area first by checking the surface tension, the liquid rate, yeah, the liquid of the weight, and also the A, the effective area, and so on, and also find the mass transfer coefficient by using these formulas. Okay, and after that, in the Onda method, you want to find the Hg and also Hl, which is using this formula Gm and divide by K, divided by the wetted area, divided by the pressure, while the H for the L is the Lm divided by KL, AW, and CT, and then the concentration, and then you want to find the overall height. Okay, the overall height. Usually, you need to calculate both of the topics there, both of the method, and then once you have the height, you usually, the one that we use for the design is the highest one. Okay, let's say for example using Cornell method, you have 10 meters height. Okay, for typical diameter, and then using Onda method, you got 8 meters. The one that the height that you calculate for design, for the further design, is the one that is highest, or maybe 10 meters. Okay, so which one is highest, Cornell or Onda? Usually Cornell is a higher, but I don't know, you want to check with your own problems. Okay, and then you also later on in the assignments, we will give you the type of the packing. So usually the graph in the book is customized for each packing. If you can't find the data inside in the book, you may be able to change your packing. For example, you use this. For example, this one is the resigring, maybe, yeah, and then pouring. But and then in the book there is no pouring, and then you can ask me or Bu Grace to confirm that you check them. You change the packing. Okay, because like I said before, each packing has the typical correlation for the flooding or for the wetted area and for the coefficient as well. Okay, and also don't forget to put the packing support. So the addition of packing support will also increase the height, yeah. So you, and then it is like to find to calculate the accessories, yeah. Okay, and then this one is also the distributor or liquid distributor. You find it, there's a lot of in internet, so many vendors, and then you can put accessories, and then this one is the hold on plate. So once you have the packing, if you remember the videos from last 2 weeks, if you have too much gas from downwards there, and then it's rising up, sometimes the packing can entrain, ya, akan terbang, ya. So to hold the packing in place, on the top of the packing we have to put hold on plate. Okay, and then here also there are example of the liquid and gas outlet, and then maybe a typical dome, but check it with the books. Usually for lower temperature you can use spherical dome head, but if you use higher temperature, it should be higher pressure, it should be hemispherical. And then don't forget to put the column support, yeah, like in your tray design. And then so this one is the typical, yeah, typical of a drawing, yeah. You may want to put, see, you put the packing support, and then you put the hold on plate. And if you use more than one pack, if you divide your packing into 1, 2 or 3 packing, don't forget you have to put the ray distributor again in the middle. Okay, the more the higher the tower, the higher the accessories, of course it's gonna increase the weight, increase your cost, yeah. Yeah, and then there should be a rule of thumb when you have to divide the packing. I think it's about if it's more than 4 meters, you have to divide the packing, but check it with the book, yeah. I'm not really sure. All right, this one is actually the one that you will be explained to me during the oral exam, yeah. So I will be asking you again about how to design the pack column. Okay, and then the last one, I think I want to just explain about the oops, this is still 2020, yeah. Should be 2021, yeah. Okay, so just explain a little bit about the assignments, yeah. So the assignments is assigned to the student as a group assignments. I have put it into the MS Team just now. And then you also you write the number as a PC 2021, and you similar to tray column, there are the report, the PC 2021 report, and also the oral exam, about 15 minutes. So one group usually around 45 to 1 hour, 15 minutes presentation, and then about 30 to 45 minutes of question and answer. That is to make sure for you to be assessed, yeah, to be assessed, and then each of you will have different assessment. Okay, and this one you also need to write for this case, yeah. You want to find the video. So okay, so the presentation for the PC is using a video presentation, so you may want to join with your friends in a Zoom, yeah. It is very easy for you, and then just do the presentation for 15 minutes, and then don't forget to record it, and then just give the recording to me, yeah. So that's also that can work as well. Okay, and then after that, after you after that I will watch your videos, and I will have description about how you do the work and how you present your work. And after that it will be tested orally after the presentation. Okay, so this is all the report. So you want to have a look, checks, yeah, to check the type and then the formats and okay, so, and then let's have a look about the general instruction. So the students are asked to design the pack column complete with the internals, like I said before, the part with internal parts, the top parts, the bottom covers, and a column support, and etc. And then just add what you think it is necessary for the pack column. And the column design has to be completed in 3 methods. The kernel, Onda, or if you want using the HiSys program. It's not necessary, but you want to try using the tray sizing, yeah, or pack sizing, but it would be good if you have tried just check it using the pack column there, just to have a good comparison. Okay, and also the assumption absorption is operated in isothermal and a constant column pressure, and then the percent recovery is 90%, and then the type of column packing is defined in this task. But if the packing doesn't meet your requirements, the group may change the packing type and size, and then the modification should be stated after the problem assignment. Okay, so like I said before, we define the type of the packing, but when you do the calculation, for example, you don't have the data or doesn't meet the requirement, you can change the packing type. Okay, and then don't forget again to check the book CNOT, Chemical Engineering Volume 6, Introduction to Chemical Engineering Design, sub 1114, yeah, the page 597. There, just share it to you as well. Just check that one. Okay, so this one is the number, the assignment for PC 1, 2, 3, and then this is the group members. Okay, I thought it is defined as well, yeah. Okay, yeah. All right, and then so what is the can you also guess when is the time? Maybe I think I can contact Dama, yeah, to check when is the time for the tri-column presentation. I think if we can do it soon. When you designing the pack column, you will have more ideas because you get feedback from me. Okay, any questions?
Bu, I
Yeah.
want to ask regarding the recording and after that the oral exam. Like, is the is the recording included as the presentation, or do we like present in the oral exam? Like, I don't know. It's actually a bit confusing.
Yeah. So for the try column, you have to do the presentation 15 minutes. But for the pack column, because you have already show me the videos, then I will go straight into question and answer. Okay,
So for the part column, we just recorded ourselves. So we present it in our own recording time, gitu, Bu.
For the try column, you do the presentation in front of me for the tray column, yeah. But for the pack column, you do the presentation with the recording.
Okay, Bu. Okay.
Okay. Any other questions? No? All right. Okay. We're actually quite a bit of limited, have a very limited time. So tomorrow I will start new module extraction. I don't know about the regular class. Maybe they will still talk about the pack column. But I think in the extraction, module, we need a lot of practice. Okay, usually we have 6 quizzes, so I will give a lot of graph to you starting tomorrow, and then we also have a lot of practice or quiz, something like that, just to make sure that you should pass the, yeah, you have a good result on the UASya, the module 3 exam, because there is no ujian perbaikan on the module 3 exam. Okay, so okay, I think time is up, so you also have another class, and then I'm gonna see you soon tomorrow with the module, with the extraction module. Thank you.